Welcome! In this short video, we are going to demonstrate how to use the evaluation tooling that we hand in as artifacts to our submission to the 24th ACM International Systems and Software Product Line Conference. While reproducing our tests, please make sure to run the service that we provide in our Docker image. If you don't know how to install DarwinSPL, how to find or launch the Docker image, or how to find the example projects, please refer to our installation and usage tutorial video. Open up the example projects containing our input feature model evolution scenarios. To measure the performance of our evolution paradox prevention, right-click on a TFM of your choice and select this entry. A dialog will appear, asking you to insert two numbers. The upper number specifies how many intermediate edit operations are to be generated during the test runs. The lower number specifies a random seed that is used for the random generation of intermediate edit operations during the tests. The default numbers here are set to the values we use in our paper. After confirming the dialog, our evaluation plugin will repeatedly generate intermediate edit operations, forward them to the connected service, and measure runtimes. The results of these measurements are stored within a folder next to your selected model. Results.log contains meta information about the test run. We distinguish between offline runtime, that is, the pure runtime of our execution semantics that runs within the service, and online runtime, that is, the offline runtime plus communication delay between DarwinSPL and the service. Evaluation results.log contains all raw runtimes. Furthermore, we generate R code that helps visualizing the results. To measure the performance of our service for the verification of feature model evolution constraints, right-click on a feature model evolution constraint model and start our tooling, similar to the procedure before. A pop-up window will appear asking to specify how many repetitions the evaluation plugin is supposed to perform. Again, the default value is set to the value we use in our paper. Confirming the dialog with a number of 5 will cause the verification of the first feature model evolution constraint within the selected module with 5 repetitions before verifying the first 2 constraints with 5 repetitions and so forth. The results of a test run are stored within files next to the selected input model, similar to the results for the test before. If you have any further questions, please leave a comment.